The next relationship that we're going to cover is composition. This is a strong form of aggregation. The composition is a special type of aggregation which denotes strong ownership between two classes when one class is part of another. That means the whole is the sole owner of its part. In composition, the lifetime of the part is dependent upon the whole. This means that if you delete the whole class, then the part class will also be deleted. The multiplicity on the whole side must be 0 or 1, and on the part side it will be based on the business rule given. To model the composition relationship, you will draw a line with a filled black diamond at the whole end. Let's look at this example. A hospital has one to many departments, but each department is part of one hospital. This means that if we delete the hospital class, all the departments will also be deleted. So in order for you to interpret this, a hospital has one or more departments, and each department belongs to exactly one hospital. If the hospital is closed, so are all of its departments. Let's look at this example. A university has many students, at least one. We know that our multiplicity is 1 to many. A student is part of only one university, and we know that multiplicity is 1 to 1. And to show the relationship, we will draw a filled black diamond by the whole part. In this case, the university is a whole, a student is a part. If the university is not functioning, all the students are also removed. That means that lifespan of the student at the university depends on the lifespan of the university. We also have constraint rules and nodes. In this example, a customer can place many orders, at least one. But there is a note that orders may be cancelled. Now let's look at a suggested method to draw a class diagram. But before we do that, let's first talk about primary and foreign keys. Every class has a primary key, which is a unique identifier. For an example, if we have a student class, we can have a student number as a primary key. That means whenever we enter the student number, we can be able to retrieve all information about that specific student. The same applies if we have a customer class. We can have a customer code or customer ID as a primary key. That means if we are searching for a specific customer, we can just enter their customer code and then we will retrieve all information about that customer. Same applies to if we have an order table on order class. We can have an order number as a primary key, which will be used to uniquely identify the records about orders. Next, we have a foreign key. A foreign key is a primary key in the foreign table or in the foreign class. We use a foreign key to link two classes. Then we have other attributes that are not used as a primary key. That means if we have, for an example, a student class, we will have a student number as a primary key, and other attributes can be student name, student surname, student email address, student phone numbers. Let's look at this example where a student is buying home equipment for their own study room. We have a student table. We start with the student number, which is the primary key. This means that If we're looking for information in a row, for instance, Robert Johnson's information, if we enter the student number, which is 11112, we should be able to retrieve all the information about Robert Johnson. This primary key is used as a unique identifier and there is no duplication. These are some of the attributes that we will find in the student table or in the student class, and they are not primary keys. We move to the order table. The order number is also used as a unique identifier for each equipment that a student wants to buy. We link these two tables with the student number. The student number is a primary key in the foreign table. Therefore, these two tables are linked together by using the student number. If we go to order number 102 of a whiteboard, we know that this was ordered by student number 11112. If we go to the student table 11112, which is Robert Johnson, therefore we know that this whiteboard marker was ordered by Robert Johnson. Now let's move forward. This is a method which is suggested to draw a class diagram. Firstly, we need to identify our classes. We need to find relationships, draw a rough sketch of the class diagram, fill in multiplicity, eliminate many-to-many relationships, identify attributes that includes primary and foreign key, map all those attributes in the diagram, and draw a fully attributed diagram. After that, you can check if you didn't make any mistake. Let's look at the next example. A company has several departments. Each department has a supervisor and at least one employee. A supervisor can only supervise one department at a time. Employees must be assigned to at least one, but possibly more departments. At least one employee is assigned to a project, but an employee may be on vacation and not assigned to any projects. So we have been asked to draw a complete class diagram based on this example. Let's follow the steps that we mentioned previously. The first step is to identify all the classes. A class can be anything real or abstract about which we want to store data. So let's go back to our example and identify all those classes. From our example, we can identify 4 classes for our system, and those are department, employee, supervisor, and project. The next step is to identify or find relationships between our classes. If we go back to our example, we can see that an employee is assigned to a department. A department is run by a supervisor. An employee is assigned to a project, or an employee works on a project. Those are some of the relationships that we can identify from the case study. Now, once we have done this, we need to draw a rough sketch of a class diagram. This is a rough sketch of our class diagram. A department is run by a supervisor. A department has an employee. An employee works on the project. So what is missing is the multiplicity that we are going to fill in the next slide. Remember, with the multiplicity, we can have 0 to many, 1 to many, 0 to 1, and we can have a range which could be, for instance, between 2 and 4, but that will be specified in any given example. Going back to our example, you can see that each department has exactly one supervisor, and the supervisor is in charge of one and only one department. That means the relationship between those two classes is one-to-one and one-to-one on both sides. Each department is assigned at least one employee. Each employee works for at least one department. So if you look at this relationship, we have a one-to-many and a one-to-many between the department and the employee, meaning the department has more than one employee, and an employee can work for more than one department. So when we go back to our multiplicity, that is going to be one-to-many for both sides. Each project has at least one employee working on it, and an employee is assigned to 0 or more projects. That means the relationship between an employee and a project is that an employee works on one-to-many projects, and from the other side, an employee may be on vacation and not work on any project, which gives us a zero-to-many relationship. Let's put this in a diagram. A department is run by one supervisor, or one and only supervisor. A supervisor can only run one department. A department has more than one employee, which is one-to-many employees. An employee can work for more than one department, which is also one-to-many. There is a problem here. We have a many-to-many relationship that we need to resolve. An employee works on one-to-many projects, and sometimes an employee may be on vacation and doesn't work on any projects. So if you look at this example, we have a many-to-many relationship. This is not required in our database. Also here, we have a many-to-many relationship between employee and the project. Therefore, in order for us to resolve this many-to-many relationship, we need to create a bridge or a composite class between the department and employee, and another bridge or composite class between employee and the project. That means we are breaking the many-to-many relationship into one-to-many relationship. We will go back to the many-to-many relationships whereby we create a composite class or a composite bridge. So now let's identify primary keys for each and every class that we have identified. Those are department, supervisor, employee, and a project. Remember, a primary key is a unique identifier. We use a primary key to retrieve information from the database, and it has to be unique, and there's no duplication of primary keys, as we previously covered that. If you are not given primary keys and you are asked to identify them, these are some of the indicators that you may use. So you can use the class name underscore one of these 5 indicators, or from the class name, if it's a long name, you can take the first 4 letters, then underscore one of these. This will help you to identify or create your own primary key. From our example, we were told that important data fields are names of the departments, projects, supervisors, employees, as well as the supervisor and employee number, and also a unique project number. This will help us when we are creating our primary keys.